This is Ruibing Chen, and this video shows my solution to question 2 of homework 10. The question 2 asks us to collect the definition of the properties of several stochastic processes. Firstly, let's focus on the property that the wide-sense stationary process. A stochastic process is called the wide-sense stationary WSS process if its expected value is constant and its autocorrelation RT1 T2 is equals to RT1 minus T2, which is only depends on the T1 minus T2. Secondly, for the independent increment processes, the independent increment process is defined by the xt1 minus xt2 and this value and the value xt3 minus xt4. These two values on non-overlapping intervals are independent, which means that the T1 to the T2 and T3 to the T4 are non-overlapping, and the probability of the T1 T xta minus xtb less than or equals to x1, xtc minus xtd less than or equals to x2 is independent. This is the definition of the independent increment process. Thirdly, the Markov process. The definition is that if Markov process, if the past has no influence on the statistics of future under the condition that the present is known, which means that the probability of the xt1 less than or equals to x1 under the condition of the xt2 equals to x2, xt3 equals to x3. This is equals to xt1 less than or equals to x1 under the condition that xt2 equals to x2, which means that the Markov process is determined by the second order. Next, for the normal process, a process xt is said to be normal if the random variables xt1, xt2, xt3 to the xtn are jointly normal. These variables are jointly normal for any n, any t1, t2, t3 to the tn. The density function is for the fx, x1, x2, x2 is equals to 1 divided by square root of 2 pi to the power of n times the square root of deterministic of the C. C is a matrix to the E times e to the power of minus 1 divided by 2 times x minus eta of the transform times C inverse, the inverse matrix of C x minus eta. Fifth, the strict sense stationary. A real stochastic process xt is a stationary in strict sense if its statistic is not affected by a shift on the time axis, which means that two processes xt and xt plus epsilon have the same statistics for any epsilon. And if a process is wide-sense stationary and it is normal, so and we can get it is strict sense stationary. Next, for the white noise, Vt is a zero mean white noise if the autocorrelation RVV T1 T2 is equals to Q T1 times the delta of the T1 minus T2. The QT1 equals the average intensity, and the white noise is a process such that its value at different times xt1, ti, and xtj are nearly independent. Actually, they are uncorrelated. Finally, let's see the mean ergodic process. The mean ergodic defines that if limited t close to the positive infinity, that 1 divided by t2 integral from the minus t to the t xt dt is equals to expected value of xt. Especially, the expected value of xt must be a constant. So if a process has expected value not a constant, it is not a mean ergodic process. And also the mean square. The mean ergodic process is mean square ergodic. The mean square means that the mean square implies that limit t to the t close to the positive infinity of the expected value of this value dt minus eta, the mean, is equals to 0. This is definition in mean square sense. Finally, let's see the martingales. A process of the xt is said to be martingale if the expected value of the xt under the condition of xs equals to x1 is equals to x1, where s less than t. The conditional mean equals to the condition. And this is the definition of the martingale.